In the previous analysis, we introduced the procedure for finding the area of an arbitrary triangle by drawing an interior perpendicular. In this example, we will introduce a procedure for finding the area of a triangle by drawing an exterior perpendicular. Here we have this arbitrary triangle and we are asked to find its area. We have seen that it is advantageously to generate right-angle triangles. So here we will draw an exterior perpendicular from this vertex to the opposite side. And of course, the opposite side B does not intersect this perpendicular, so we will extend the opposite side and form this right-angle triangle. So here we have the original triangle, let's call it T. We have the triangle given by the blue dots, let's call it T blue. And then we have the new formulated larger triangle given by this with vertices with the red circles. And let's call this triangle T red. Now, the area of the original triangle T, the area of the original triangle T will be equal to the area of the red triangle minus the area of the blue triangle. Notice that both the red and the blue triangles are right-angle triangles. So the area of the red triangle will be equal to the product of the perpendiculars. And here we observe something interesting. We do not know the length B1, which the product of the perpendicular, the length of the perpendicular will be B plus B1, nor do we know the height of the second perpendicular. So we'll come to that in a second. Also, the area of the second triangle, TB, is the product of the perpendiculars, in this case B1 times H divided by 2. So if we perform the subtraction here, we find out that the area of the original triangle is equal to B plus B1 times H divided by 2 minus B1 times H divided by 2. And of course, this is subtraction of two fractions. And we can take the next step, put them under a common denominator. They have the same denominator. And I'm going to skip one algebra step. And I'm going to say here that the final result is B times H divided by 2. I will let you evaluate this result. So what do you observe again? Similar to the previous case, the area of a triangle is the product of the length here, B, divided by the opposite perpendicular. The question, though, that arises is that what is this perpendicular height h? We do not know that. However, given the analysis that we have performed before, we should be able to evaluate h. So let us go ahead and see how to evaluate h. I'm going to redraw here. I'm going to redraw this information. This is h. This is B1. And I'm going to make the following assumption. I'm going to assume that sides A, B, C and angles alpha, beta, and gamma are known. Why do I make that assumption? Because from our previous analysis, given any minimum information, we could use the law of sines, the law of cosines, and find all the angles and all the sides in a triangle. So considering that, let us proceed. So here we observe that this angle alpha is known. Then this angle here that side C makes with sides B and B1 could be called alpha 1. But angle alpha plus alpha 1 is equal to 118 degrees. And from here, we can solve and find angle alpha 1. So in this new triangle, we know the angle alpha 1. Also, we know side C. And we also know that we have here a right angle as well. So let's call this gamma 1 for completeness. And then I'm going to go up here to where the angle beta is and say that this angle here is beta 1. So going back, we know now angle alpha 1, we go side C, we know angle gamma being 19 degrees. We will use the information from angle alpha 1 and from gamma in order to find angle beta 1. So the sum of the three angles of a triangle, alpha 1 plus beta 1 plus gamma 1, is equal to 118 degrees. But in this expression, we already know angle alpha 1, we already know gamma 1 is 90 degrees. So from this expression, we can solve for beta 1 as 180 minus alpha 1 plus gamma 1. So at this stage, we know, let us summarize, we know for the blue dot triangle, we know all angles alpha 1, beta 1, and gamma 1. And we also know one side, which is the side C from original triangle. So with this information, knowing all the angles and one side, our previous analysis on analyzing triangles should be sufficient to evaluate what? To evaluate B1 or H. And somebody is going to say, hey, who cares about evaluating B1 at this stage, right? All I'm interested is H, because the area is B times H divided by 2. So I will leave it up to you as an exercise to revisit the theory and identify which law you will use, either the law of sines or the law of cosines, to evaluate side H as advantageously as possible with the minimum number of calculations. So with this analysis, we have seen how to draw either interior or exterior perpendiculars and evaluate the area of an arbitrary triangle. This triangle that we just analyzed could be evaluated by drawing an interior perpendicular. As we have seen earlier. So if we apply the theory that we have, we could say that the area of this triangle will be equal now with the product of side A the product of side A times the perpendicular on that side. Let's call this perpendicular y divided by 2. So I would like for you to perform similar analysis with information that is known and evaluate the length of side y, or perpendicular y. And then compare the expressions for the area.